Dear students, last time we have seen one numerical problem based on Nernst distribution law. Let us see today another numerical problem based on Nernst distribution law. The numerical problem given here is following data were obtained for distribution of an organic acid HA between benzene and water at 25 degree centigrade. The given data is concentration of acid in aqueous layer in moles per dm cube is 1.50 into 10 to the power minus 2, and the corresponding concentration of acid in organic layer is 2.42 into 10 to the power minus 1. In second experiment, the concentration of acid in aqueous layer is 1.95 into 10 to the power minus 2, and the corresponding concentration of acid in organic layer is 4.10 into 10 to the power minus 1. And in third experiment, the concentration of acid in water is 2.89 into 10 to the power minus 2, and the concentration of acid in benzene is 9.07 into 10 to the power minus 1. Neglecting the dissociation of the acid in water, predict the molecular state of the acid in benzene. So, this is what the numerical problem we have to solve. When we read this numerical problem carefully, we will see that in this numerical problem, it is clear that the solute under examination may exist in normal state or in associated state in either of the solvent. Therefore, in this case, we have to apply at first normal Nernst distribution law and see whether the partition coefficient values are constant or varies from one experiment to another experiment. The next important thing in this particular case is the dissociation of acid in aqueous layer is to be neglected, because we know organic acids dissociate to some extent in water. However, in this case, it is clear that we need not apply modified Nernst distribution law for what? For the dissociation of solute under consideration in one of the solvent, and one of the solvent in this particular case is water. So let us see how can we apply the Nernst distribution law to given data and find out the molecular state of the solute. We know that the solute acid in this case may exist as normal molecules in both the solvents or as associated molecules in either of the solvent. In first case, that is when solute, in this case an organic acid under examination, exist as normal molecules in both the solvents, at that time obviously the ratio of what the concentration of organic acid in organic layer to the concentration of organic acid in aqueous layer will be constant. On the contrary, if solute undergoes association in either of the solvent, in that case the ratio nth root of C1 upon C2 will be constant. So let us apply here at first the normal Nernst distribution law and see whether the acid under consideration exists as normal molecules in both the solvents or exist as associated molecules in benzene. So let us calculate the partition coefficient of organic acid HA in each case applying normal Nernst distribution law to the given data. Let us suppose here this data is obtained in experiment number 1. Second set of data is obtained in experiment number 2, and this data written over here is obtained in experiment number 3, carried out under identical conditions at 25 degrees centigrade. Let us calculate partition coefficient of organic acid between benzene and water in case of experiment number 1. Now, when we look at the numerical values of concentration of acid in aqueous layer and the concentration of acid in organic layer, we will find that the concentration of organic acid in organic layer is higher in each case than the corresponding concentration of acid in aqueous layer. So, for simplicity and our convenience, and at the same time the IUPAC convention, let us consider the concentration of organic acid in organic solvent, that is the concentration of organic acid in benzene is C1 and the concentration of organic acid in aqueous layer is C2. Once we understood this, once we consider this, the concentration of organic acid in benzene is C1 and the concentration of organic acid in water is C2. Let us calculate partition coefficient of organic acid between benzene and water in experiment number 1. So Kd in experiment number 1 will be equal to C1 upon C2. Here C1, the concentration of acid in benzene is 2.42 into 10 to the power minus 1 moles per dm cube, and the concentration of organic acid in water is 1.50 into 10 to the power minus 2 moles per dm cube. Moles per dm cube cancels, and we will get in this case the partition coefficient or the distribution coefficient of organic acid HA between benzene and water in this case is 15.92. In this way, we have calculated partition coefficient of organic acid HA between benzene and water in experiment number 1. Let us calculate partition coefficient of acid in experiment number 2. I write it here. In experiment number 2, Kd is equal to C1 upon C2. Here C1, the molar concentration of organic acid in benzene is 4.10 into 10 to the power minus 1 moles per dm cube upon the concentration of acid HA in water is 1.95 into 10 to the power minus 2 moles per dm cube, and here the partition coefficient or the ratio of C1 upon C2 is 21.03. Let us calculate the partition coefficient of acid in experiment number 3. Experiment number 3, Kd is equal to C1 upon C2. Here C1 is equal to 9.07 into 10 to the power minus 1 moles per dm cube, moles per dm cube. The concentration of organic acid in aqueous layer is 2.89 into 10 to the power minus 2. It becomes 31.38. Let us compare the numerical values of partition coefficient in experiment number 1 with experiment number 2, and partition coefficient of organic acid in experiment number 2 with 3. When we compare the numerical values of partition coefficient of organic acid between benzene and water, in this case we see that the numerical values are different. There is no any consistency in the numerical values of partition coefficient when we apply normal mass distribution law, that is C1 upon C2 is equal to Kd for given data. Look at the partition coefficient which we have calculated using normal Nernst distribution law, Kd is equal to C1 upon C2 in experiment number 1 is 15.92. In case of experiment number 2, the partition coefficient of organic acid between benzene and water is 21.03, and in last experiment the partition coefficient of organic acid between benzene and water is 31.38. The numerical values which we have obtained in this particular case, which we have calculated, are not constant. All these values varies from each other: 15.92, 21.03, 31.38. This clearly indicates that the solute under examination, in this case the acid HA, does not exist as a normal molecule in both the solvents. It must be undergoing, in this particular case, in association in either of the solvent. Let us suppose the acid HA is undergoing association in benzene and giving the associated molecules HAN. In other words, let us apply modified Nernst distribution law to the given data and calculate the partition coefficient. Now, the modified Nernst distribution law which we have to apply in this case is nth root of C1 upon C2. So Kd in case of experiment number 1 will be equal to nth root of C1 upon C2, where nth root of C1 represents the concentration of organic acid in benzene, and C2 represents the concentration of organic acid in aqueous layer. Let us substitute the numerical values of N, C1 and C2. Let us suppose the acid in this case undergoes association in benzene, and the associated molecule is made up of two normal molecules. In other words, the associated molecule is a dimer. In other words, the numerical value of N is equal to 2. So we know that when the nth root is equal to 2, at that time we need not write there 2. So let us write it here, the numerical values of C1. The numerical values of C1 in this case, the 2.42 into 10 to the power minus 1 upon 1.50 into 10 to the power minus 2. So the partition coefficient in first case is equal to under root 2.42 into 10 to the power minus 1 upon 1.50 into 10 to the power minus 2. And here we will find that the partition coefficient in experiment number 1 is equal to 32.36. Let us calculate the partition coefficient of organic acid HA between benzene and water in experiment number 2. In experiment number 2, experiment number 2, Kd is equal to under root C1 upon C2. Here C1 is equal to 4.10 into 10 to the power minus 1, and C2, the concentration of organic acid in water is 1.95 into 10 to the power minus 2. And when we calculate this, the ratio of square root of C1 upon C2 in experiment number 2, we get 32.84. Let us calculate the partition coefficient of organic acid in case of the experiment number 3 using modified dose distribution law. Nth root of C1 upon C2. Here C1 is equal to 9.07 into 10 to the power minus 1 divided by 2.89 into 10 to the power minus 2. And when we solve this, square root of 9.07 into 10 to the power minus 1 upon 2.89 into 10 to the power minus 2, we get 32.95. When we look at the numerical values of partition coefficients of organic acid HA between benzene and water in experiment number 1, experiment number 2 and experiment number 3, we will find that the numerical values of partition coefficients are fairly constant. In experiment number 1, the numerical value of partition coefficient is 32.36. The numerical values of partition coefficient, when we apply modified dose distribution law, that is Kd is equal to square root of C1 upon C2. In second case, we get 32.84. In case of experiment number 3, the ratio Kd is equal to under root C1 upon C2 is equal to 32.95. This clearly indicates that the organic acid HA exists as associated molecules in solvent benzene, and the numerical value of N is equal to 2. In this way, we have seen how can we predict the molecular state of the molecule solving numerical problems using normal nurse distribution law and modified nurse distribution law. So at last we have to predict the molecular state of the acid HA in benzene, and here the molecular state of the organic acid HA in benzene is HA2. In other words, HA, the organic acid HA, exists as a dimer in benzene. I hope you understood how we have applied normal nurse distribution law at first to the given data, and checked the numerical values of partition coefficient in each case, we have seen when we apply normal Nernst distribution law, that is Kd is equal to C1 upon C2 for given data, the numerical values, whatever numerical values which we get are not consistent, varies from first value to final value, first value to third value. In other words, the numerical values when we apply normal Nernst distribution law are varying, are not constant. On the contrary, when we apply modified Nernst distribution law, Kd is equal to under root C1 upon C2. We have seen that the numerical values are fairly constant, and therefore the acid Ha in this case exist as associated molecules in solvent benzene, and the numerical value of M is equal to 2. With this, I stop here. Next time, we'll see few more numerical problems. Thank you very much.